So I had a go at these two programs, Lucas-Kanade and another one, Gunnar-Farneback, and they ran alright, not too many problems. Anyway, so let's run this Lucas-Kanade. I'm recording this because I don't think this is good enough for the presentation. So what this Lucas-Kanade one is, let's close that. Right, okay, so it looks at you click on the mouse and it draws a dot. So you need something with a sharp, so let's try this. That was good, because it's got the contrast between the white and the black. Right? So it's good on hair, because there's a contrast, and it works on hair. So when I click on my forehead, it will jump and disappear, because there's no contrast. If I want to track my finger, it'll mess up because there's no contrast. So our tray needs to have a deep contrast between it and the background. Now as you can see, this one just disappeared, so as soon as our train reaches the gantry or gets covered, we lose the point. So every time the train reaches the gantry we lose the point, it just looks silly. Yeah, and the fact that we can just move points around, I think that's just silly. Yeah, okay. So I thought this was quite strange. Yeah, there we go, got rid of the points. So if you got, so in the previous ones we were doing examples with this cup, and if I click on it, no contrast, so you can't track it. So it tries to track my fingers now, and we've got one corner, because there's a contrast between it and the outside. But before I was having trouble with that, actually getting this to click on any dots with it. Like now, I can't click, it's following something else, so this doesn't work. And let's try with this. So the contrast between the white and the red, but it just goes. I didn't really like this demo, it doesn't work very well. The dots disappear, sometimes they go, and it is in good contrast, it just misses it, so not that good. I then went to the other one, which was the Gunnar-Farneback method, and let's try that out. There was okay, so this looks at any motion of the points and draws a line between it and the next frame. So if the next frame, so if I've got this, my hand, so right now my hand's still, all the dots are still. Now all the dots I'm going to move are going to have a line on them. So it says, look, the dots have moved, so there's a line on them. So as the train is going past, it's going to see a load of dots moving out of the way, like that and like that. I'm not sure how relevant that is in the demo. It's just seeing dots moving, it's not actually tracking anything. And then when I saw these reminded me of let's stop that, of these Python demos, because when I first tried it out, I tried these Python demos, and these are Lucas-Kanade, same ones. If I run this, alright, so there's a lot of dots, and rather than you clicking on the dots, it shows you every possible dot and tracks you. So these are the available dots that can be done, rather than you spending some time clicking on them. And there it is. And so on that, see, you can't click on the inside, but there's some dots available on the outside. They move around a bit, and you can tell you at the top there's about 800 dots on there. There's a lot of dots on the hair. It seems to be quite good at the hair, and the eyes, and the eyebrows. It's quite good at that. And let's close that. And there's another one which is track. This is like the first one, but it shows less dots, so the more prominent ones. And see, the only ones with the contrast, it's looking at the contrasts and edges. There's a lot of contrast between the black and the white. And here, the black on the pupil, and the white on the outside. Here, nostril, beards as well on the edges, and there's a lot of contrast here, black on the white. It seems to be quite good at these contrast levels. Now if we use this with this, I think the contrast is between my hands on the outside rather than the circle. There's a tiny bit of contrast, but we seem to be losing it sometimes. So if this was a train, if the train was like that. This has a bit of contrast, so you can see we sort of got it, but we sometimes miss it. So some of the times in the demo it might not work. And the train would have to stop every time, because if you go too fast, you could lose it. Now let's say this train was black and I'm using this mouse. It seems to be okay when it gets a dot and it moves slowly out the corner. Whereas sometimes if something passes over it, like it passes over a gantry, it can lose position. I didn't find this to be optimal, because you can lose some position if something goes under it, like it goes under a gantry. So it's tracking, goes under a gantry, loses track, and sometimes it gains tracks. But it's not that good, and they'll see straight through it, because these just look like the demos. There's one more demo, which is this optical flow. Oops. Let's try that again. Alright. Optical flow. Alright, this is just like the ones that, I think the first or the second one, or the first one, I can't remember which one. But anyway, it looks at the difference between the dots and moves them around. So these are just like the demo programs. I'm not sure how relevant these are for our demo.